Dear children, today I would like to share with you an important topic in electrochemistry, that is Nernst equation. Myself, Dr. Digna Varghese. Nernst equation. In electrochemistry, the Nernst equation is an equation that relates the reduction potential of a reaction. It is a half cell reaction or a full cell reaction to the standard electrode potential, temperature, and activities, often approximated by the concentrations of the chemical species undergoing reduction and oxidation. It was named after Walter Nernst, a German physical chemist who formulated the equation. Nernst equation was named after the great German physical chemist whose name is Walther Nernst. He formulated the Nernst equation. Effect of electrolyte concentration on electrode potential, that is given by the Nernst equation for electrode potential. The Nernst equation shows how the potential of an electron depends upon the electrolyte concentration and temperature. For a metal ion electrode, that is denoted by M bar Mn plus, for which the reduction electrode reaction is Mn plus N electron giving metal solid. Here Mn plus is the metallic ion in aqueous solution, undergo reduction reaction by accepting electrons and forming metal electrode or metal in the solid state to electrode. So here the Nernst equation may be given as EMF of the electrode is equal to standard EMF of the electrode minus RT by NF ln concentration of solid metal divided by concentration of metal ion. For a metal ion electrode, the reduction reaction is that Mn plus N electron giving metal solid. The Nernst equation may be given as E electrode is equal to E0 electrode minus RT by NF ln concentration of metal divided by concentration of metal ion. Since concentration of solid metal is regarded as unity, so the equation one is this. So the equation 1 is modified as E electrode, EMF of the electrode or standard electrode potential of the electrode minus RT by NF ln 1 divided by concentration of metal ion. We take concentration of metal ion is regarded as unity. So that given as equation number 2. Here the electrode potential of the electrode is equal to standard electrode potential of the electrode minus 2.303 RT by NF log 1 by Mn plus concentration of metal ion. Natural logarithm is converted to ordinary logarithm by multiplying with a constant 2.303. Here that is equation 3. The Nernst equation is that electrode potential of the electrode is equal to E0 electrode plus 2.303 by RT by NF log concentration of Mn plus, that is log 1 by Mn plus, we can say minus log concentration of Mn plus. Minus of minus is plus here. Okay. Therefore, the Nernst equation is given as E electrode is equal to E0 electrode plus 2.303 RT by NF log Mn plus, where EL is the reduction potential of the electrode. Reduction potential of the electrode. This is the reduction potential of the electrode. E0 EL is the standard reduction potential of the electrode. R is the universal gas constant and T is the Kelvin temperature, and F is the Faraday constant. Its value is 96,500, and N is the number of electrons involved in the balanced equation for reduction. Concentration of Mn plus is the molar concentration of metal ions. Okay, so this is the Nernst equation, which depends on the electrolyte concentration and temperature. Okay, other terms are constants. Nernst equation. We know the Nernst equation is that reduction potential of the electrode is equal to standard reduction potential of the electrode plus 2.303 universal gas constant into Kelvin temperature divided by number of electrons involved in the balanced equation for reduction into Faraday constant log concentration of molar concentration of metal ions. Here we know R is a universal gas constant and its value is 8.314 joule per Kelvin per mole, and if F is also a constant, that is Faraday constant, 96,500 coulombs, and T, if temperature is kept constant at 298 Kelvin, Nernst equation is simplified as in the forms, that is EL is equal to E0 EL minus 0.0591 divided by N log 1 by Mn plus, concentration of Mn plus. By applying the value of R, T and F here, we will get a quantity that is 0.0591. In general, we can represent this in other forms also, that is E electrode is equal to E0 electrode plus 0.0591 by N log concentration of metal ion. Here 0.0591 divided by N log concentration of metal ion. That is 1 by Mn plus is replaced by minus log concentration of Mn plus ion. So minus of minus is equal to plus here. Okay. So the Nernst equation is simplified in the form reduction potential of the electrode is equal to standard reduction potential of the electrode plus 0.0591 by number of electrons involved in the balanced equation for reduction into log molar concentration of metal ion. Here we are representing a general electrode reaction, that is oxidized state plus N electron gives reduced state. The electrode potential EEL for any electrode, metal, metal ion or any other redox couple is given by the Nernst equation, that is given here. Reduction potential of the electrode is equal to standard reduction potential of the electrode minus 2.303 RT by NF log concentration of molar concentration of reduced state divided by molar concentration of oxidized state. that can be simplified as we apply the universal gas constant value 8.314 if the temperature is given at 298 Kelvin and the Faraday constant is 96,500 coulombs, we will get a simplified form of Nernst equation, that is standard reduction potential of the electrode, reduction potential of the electrode minus is equal to standard reduction potential of the electrode minus 0.0591 by n log molar concentration of the reduced state by molar concentration of the oxidized state. For general electrode metal ion reaction, the Nernst equation is given here. For an example similar to metal ion electrode, that is here you can see ferrous ferric electrode, the reaction is here n is equal to 1. The reaction is like that, Fe3 plus electron giving Fe2 plus. Okay, Fe3 plus 1 electron accepting giving Fe2 plus, that is its reduced form. Here n is equal to 1. Number of electrons involved in the balanced equation is 1 here. So therefore the Nernst equation becomes electrode potential for the ferrous system is equal to standard electrode potential for the ferrous system minus 2.303 RT by NF log reduced state, that is ferrous, molar concentration of ferrous iron divided by molar concentration of oxidized state, that is ferric. So we can use the general electrode reaction for any other redox coupled electrodes or metal ion electrodes, and we can calculate the electrode reduction potential for that particular electrode. Thank you for your attention.